Nanotechnology is a developing and very promising field now, studying and creating technologies that allow manipulating individual atoms and molecules of 1 to 100 nanometers in size. The most important task of nanotechnology is the design, creation, synthesis of materials and objects with predetermined properties.
Let's talk about how it works. The nano device interacts with the environment using sensors. A nanodetector is a device that also has nanoscale dimensions designed for qualitative and quantitative analysis of environmental parameters. Typically, nanodetectors consist of 3 elements: a receptor layer, a measuring transducer, and an amplification, processing, transmission, and display system. The receptor layer contains chemical compounds capable of interacting with the object under study, for example, a gas that needs to be detected. This layer can be affected by temperature, pressure, a certain level of chemical elements content. The second element of the nanodetector converts the effects on the receptor layer into an electrical signal with certain parameters and characteristics. The third element processes and displays the received signal.
There are 2 classes of nanosensors. Sensors that differ from conventional electronic ones only by using nanoparticles in a sensitive layer, and photometric and chemical nanosensors that interact with molecules of substances or electromagnetic fields. Sensors of the second class are able to signal the presence of the desired chemical elements in the environment. A light source is required to take readings from them.
One of the first such developments was a nanotube-based mass sensor, which could be used to determine the weight of even a single molecule. It was in 1999.
In fact, by now nanodetectors are already affecting various areas of our lives, from security and energy to the chemical and pharmaceutical industries and medicine. For example, many security programs are now moving to the nanoscale. Airports use devices capable of detecting anything that emits measurable molecules, explosives, or any impurities in the air that can be used as biological weapons.
In pharmaceuticals, during the production of a certain medicament, chemicals move along a conveyor belt, which must be regularly cleaned to a very small concentration of excess particles. Previously, to make sure that the conveyor was clean, it was necessary to send samples to the laboratory, but now we use a device that captures particles and impurities in real time. That is, we are talking about nanodetection.
And of course, it is impossible not to mention the field of medicine. Nanopore DNA sequencing sensors are used here to obtain rapid genetic analysis, nanoparticle health sensors that allow you to track various indicators such as blood sugar or oxygen levels, and sensors the size of red blood cells that detect cancer cells, hold them or transmit a certain signal to them.
Nanotechnology is a developing and promising field. In conclusion, I can say that nanosensors will be useful wherever there are limitations on weight or size, and measurements or diagnostics of great accuracy are required.